Yo, what's up everyone? Welcome to the 2017 USNCO local exam, descriptive/laboratory chemistry section. So we're going to be doing questions 7 through 12. Let's start with question 7. A white ionic solid is dissolved in water. Addition of a solution of sodium chloride to the solution results in a white precipitate. What was the cation in the original ionic solid? Well, since we're dealing with a precipitation reaction, we're going to be dealing with a double displacement or a single displacement reaction. What that means is that the cation is going to pair up with the anion. The cations are going to be the cations that we have as our answer choices, and our anion is going to be the anion from the sodium chloride. And the anion from our sodium chloride is the Cl-, is the chloride. So we have to determine which combination of anion and cation are going to be insoluble. We have NaCl, we have iron chloride, we have silver chloride, and we have strontium chloride. And so which one of these are going to be insoluble? If you look at your solubility rules for chloride, all chlorides are going to be soluble except for silver, lead, and mercury. And the only one that is insoluble in this case is going to be the silver chloride here. So our answer is answer choice C. All right, let's move on to question 8. An element is a solid at room temperature but soft enough to be cut with an ordinary knife. When placed in water, the element reacts violently. Which element is it? This is really characteristic of an alkali metal, and you could totally verify this if you looked at their metal reactivity series. But the only alkali metal that we have here is answer choice A, which is sodium. Let's go to question 9. A 0.1 molar solution of which salt is the most basic? Alright, so let's go through all the answer choices. Two of them you can get rid of right away, and one of them is going to be A, NaNO3. NaNO3 is going to be produced in an acid-base neutralization reaction. And the reactants that are going to produce this are going to be nitric acid, HNO3, and NaOH. The way you can find this is by reverse engineering a acid-base neutralization reaction. So we know that at the end of the reaction, you're going to be producing that salt and water. Now, because we have this, we can now reverse the reactants. And the way we do that is by knowing the fact that this reaction is a double displacement reaction. So the cation in this salt is the sodium, the anion is the nitrate, and the cation here is the H+, and the anion is OH-. Using that, you can find the reactants because you know that the cation is going to get paired up with the anion and vice versa. So you're going to have Na being paired up with the OH, NaOH, and you're going to have the H being paired up with the NO3, so you have HNO3. And that's how you find the reactants that produce any salt. The significance of these reactants in particular is the fact that HNO3, nitric acid, is a really strong acid, and sodium hydroxide is a really strong base. When you have a strong acid and a strong base reacting to form a salt, your salt is going to produce a neutral, is going to be neutral in solution. So it's going to be neutral. And basically the same can be said for answer choice B. So we have NaClO4. The reactants that produce this are going to be perchloric acid, so HClO4 and NaOH. And these are the exact same. Perchloric acid is a strong acid, and sodium hydroxide is a strong base, so this is also going to be neutral. Because of that, we know that A and B cannot be the right answer. But now we have to look at C and D. So we know that A and B are not correct. Let's look at NaHSO4. Now, NaHSO4 is going to break up into Na plus and HSO4 minus ions. Now, the thing about that HSO4 minus is the fact that it's going to also break up. What that means is that it's going to react with water. It's going to hydrolyze. And when it does react with water, so NaHSO4 is going to react with water to produce, first of all, hydronium ions and SO4 minus ions. Now that hydronium ion is going to make this salt be a be partially acidic when dissolved in solution. So it's not going to be C. Therefore, it has to be D, but let's look at why. So the salt that we're dealing with here is going to be NaHCO3. Now, a similar thing's going to happen. So it's going to get, when it's in the solution, it's going to get split up into Na plus and HCO3 minus ions. And that HCO3 minus is going to be similar to what we saw before. But in this case, it dissociates into different things. So the HCO3 minus is going to react with water, but instead of hydronium ions, we're going to be producing carbon dioxide, OH minus, and also water. And because we have this OH here, this means that this solution, when dissociated in a solution, is going to be basic. So our answer is D. All right, let's go to question 10. Addition of small amounts of which solids at 2 4 molar hydrochloric acid will result in gas evolution. All right, so we're gonna have to go through all the answer choices, so or both of our options here. So let's look at the first one. We have hydrochloric acid being reacted with zinc. This is a single displacement reaction, so the anion gets paired up with the cation. The cation is the zinc and the anion is the chloride. Zinc usually has a charge of 2+, so it's going to be zinc chloride 2, and we have hydrogen on its own. But hydrogen cannot be on its own. It's a diatomic element, therefore it needs a subscript of 2. Now this isn't balanced, but I'm not going to balance it for the sake of time. But H2 is a diatomic element, and it's one of your diatomic elements that are gases at standard conditions. So you do have a gas evolution happening here. So zinc checks out. Let's look at Na2SO4. We have hydrochloric acid with Na2SO3. Same thing happens. We have a double displacement reaction, so we have NaCl and we have H2SO4. Both of these are technically aqueous, but remember the H2SO4 doesn't like being in this state. It almost immediately dissociates into water and SO2. Oh, I made a small mistake. It should be a SO3, sorry. So yeah, SO3, and that dissociates into a gas, which is the SO2. So you have a gas evolution happening with both your answer choices. So our answer is C. All right, let's go to question 11. A student determines the acidic acid concentration of a sample of distilled vinegar by titration of 25 ml of the vinegar with standardized sodium hydroxide solution using phenolphthalein as an indicator. Which error will give an acidic acid content for the vinegar that is too low? All right, let's go through the answers. So A, some of the vinegar is spilled when being transferred from the volumetric flask to the titration flask. If the vinegar is spilled, then your concentration of the concentration that you're titrating is going to be lower. Therefore, it's gonna require less NaOH, and that's gonna end up making your acidic acid content too low. So A does check out, but let's look at the other answer choices to make sure that A is the right answer. B, the NaOH solution is allowed to stand for a prolonged period after the standardization and absorbs carbon dioxide from the air. When it absorbs carbon dioxide from the air, the NaOH solution that you're using to titrate is being, unpurified. So what that's going to do is that you're going to need more and more of that NaOH unpurified solution to titrate your entire acidic acid. This is going to give the illusion that you need more sodium hydroxide to titrate a certain concentration, and when you need more NaOH, it's going to inflate the concentration of the acidic acid. So that means B cannot be the right answer, since that'll make the acidic acid concentration too high. C, the endpoint is recorded when the solution turns dark red instead of faint pink. When it turns dark red, then that means you've added too much sodium hydroxide. And when you've added too much sodium hydroxide, that will also inflate the concentration of acidic acid, so it can't be C. And D, the vinegar is diluted with distilled water in the titration flask before the NaOH is added. Diluting it lowers the concentration, therefore you're going to need more sodium hydroxide, and that's going to also inflate the concentration of acetic acid. So D is also wrong, and therefore the only answer that we have is A. Let's go to the last question. Which piece of equipment will give the most precise delivery of 25 ml of a solution? So A, 25 ml graduated cylinder. That's an okay choice. A graduated cylinder would be a pretty good option. B, 25 ml syringe. You don't really use syringes. C, 25 ml beaker. A beaker does not count as volumetric glassware because it's not accurate enough, so you really shouldn't be using it to have the most precise delivery. So you wouldn't use a beaker. D, a 25 ml volumetric pipette. Now, a 25 ml volumetric pipette is going to be more accurate than a 25 ml graduated cylinder. So you would use a pipette instead of a graduated cylinder. Just a quick note though, is if the question asked what would be the most precise way to give a 20 ml delivery, then the answer would be a graduated cylinder. And that's because a pipette, I'll try to draw it, a pipette only has one marking. If you've reached that marking, that's 20 mils or 25 mils, but there's only one marking, so you would have no idea when you've reached 20 mils. On the other hand, a graduated cylinder has a bunch of markings on the side, which would let you know when you have hit 20 mils. But for the case of this question, 25 mils, you would totally use a 25 mil volumetric pipette. And that's it for the 2017 USNCO local exam descriptive/laboratory section. I hope this was helpful, and I hope to see you later. Thank you.